Hello everyone, I'm Eystein Hansen of ADA Nord Pool, a staking pool in the Cardano ecosystem. When I'm recording this today, it's a beautiful sunny day here in Norway. But I'm thinking also, just imagine such a beautiful day it's going to be with the summit, because we are going to show everything the community has done so far and also what we are reaching for. And I believe Cardano is a project that actually could influence and help make the world a better place. And I guess that's a bit the topic of my own presentations. It's about collaborative mechanisms in the Cardano ecosystem. And we're going to start with looking at some of my own projects and my own background, because I have some projects that I have been part of that's actually also collaborative efforts with other Cardano community members. So with that said, let's get started. Let's look first at my own background in the next slide. Okay, so for the second slide on my presentation, we're looking a bit in my background in the community. As you can see, I have my own logo, ADA Nord Pool, and actually now I have 2 home servers, but also 2 remote servers. And we're going to talk a bit about how I came to this point, as it also involves the community effort and how we collaborate together. I started back in December 2017, and was mostly just curious, reading the research paper from the iohk.io page, and I started more discussing with the other community members in the forums in January 2018 and onwards. And back then I was mostly worried about we needed to have a more decentralized staking pool operation, where we were not located in a few countries but all across the world. So staking pool operator decentralization was one topic, and I was also interested in something called a legal domain specific language, or legal DSL. One of my forum threads were about the research that's already been done into legal DSLs, and also discussed how can this be used in the community, because if you have a language that's very specific, for example, for writing a legal contract, you can more easily use this for a smart contract as well, how to write legally binding contracts. So I found that also a very interesting subject to discuss in the community. But back then it was more discussions. It all started to become much more interested in 2019, because at the end of that year, there was something called the incentivized testnet, and during this time with the incentivized testnet, we actually got a huge growth in the number of pool operators. It started, well, I was registered in the 13th December, and we were just a few pool operators. I knew everyone by name, but after 6 months, now there's more than 1,000 active staking pool operators. So at least staking pools, we don't know how many operates them, but that's an amazing growth. And it says something also about the process the community has been through, because during that time, for example, take me myself as an example. Then I was knew Linux, but I did not know how to tweak a kernel for network performance. I did not know how to use optimal time syncing to make sure your server was synchronized with the time across the world. I did not know, for example, also how to write like monitoring scripts, how to check the health of your nodes. I was not used to using UPS and internet redundancies and stuff like that to keep the server going no matter what happened. And I certainly was not used to having to do updates on one server while the other kept running, so that there was never any delay in operations. But I came to that point because we as a community, we shared the knowledge with each other. It was never an environment of secrecy. It was more an environment of, oh, I have this cool script. Can you look at it? Maybe try to tweak on it, and it developed from there really. And I would probably never be in the place I am now with my staking pool if it was not for that community effort. And I think it's very interesting now that the ITN was supposed to end, the incentivized testnet was supposed to end now, at least the reward portion of it was supposed to end now the 19th of June. But because they see it as the success it's actually been, they're also considering now, should we keep going? And should we use this ITN for something else? And actually they're going to try now to vote on this. And that's I find that very interesting, because maybe we can have a same type of process with governance issues, with how we collaborate, and the same type of learning process as we have done with as a staking pool operator. We could have that for how do we propose changes, how do we structure the debate, how do we formalize the documents to propose these changes, and learn from that kind of process again. So I really hope to see this ITN continue in some way or form. I don't think it would be a competitor to Cardano. I think, in fact, it will enrich Cardano, because Cardano is built for sidechains. It's built for being very easy to adapt to other cryptocurrencies. And yeah, it's built to collaborate as a cryptocurrency. So if we keep this ITN going, we will have to have this debate now, and then we will find out what we can use it for, and then we'll actually vote on it on the chain itself. So again, it's a very interesting example of what processes are currently going on, that we are learning about governance issues, about voting. And before we move on, because I will now try to look a bit more in what are some other type of projects that we're currently doing that's showing some collaboration. But before that, I want to say that, of course, I'm no expert on these topics. I am a community member. I have a background in law and psychology, but this is not my domain of expertise, collaborative processes. It's more like what I see as a community member and some of the things I wish we can do better, and my comments on that. Alright, so in this slide 3, we're going to look at the off-chain collaboration examples. On the left side, you see something called Falling at Home, and we're actually already number 600 out of several hundred thousands in that project in donations of CPU power. And I think I will talk about that first, and after that we'll talk about the Kiva lending as well. So the Falling at Home started as a community effort during the COVID-19 crisis. It was the community manager at the Cardano Foundation, Andy Hendricks, who proposed it in a forum post. That we should try also to give our efforts to this. Basically, the Falling at Home, it uses GPU or CPU power to calculate and fold proteins. And during the COVID-19 crisis, one of the ways they are folding the proteins and how they are calculating, they're actually looking at the COVID-19 virus, how it uses the proteins to protect its cells. So probably very useful to understand better. And it's very interesting because by having this proof of stake protocol, like Cardano does, you don't need to use that much of the CPU or the GPU, not at all, because it's a very efficient protocol. It's not trying to solve the hardest problem and increasing the difficulty. It's trying to select people based on the total stake, and that's a very different approach. And that approach actually enables Cardano to do things like this, to donate its CPU power, its GPU power from the staking pool operators. And as a staking pool operator myself, I of course jumped at this chance. Because I believe we as an ecosystem, we should try to do as much good as possible. There's plenty of negative stories in the media, how cryptocurrencies are used for bad, for criminal activities and such. And we need more positivity because we, the community, we consist of everyday people, and we're trying to do better. We believe in this project because we're trying to make the world a better place. I know that sounds cheesy, but it's actually true. And in this case, it's a small step, but it was actually very meaningful because when you have the staking pools, they're online 24/7 because you're always ready to produce a block if you are drawn from the lottery based on your stake. So it's sitting there, this idle power. It can be used for donating, and with just donating of a few of the community members, it climbed from the very lows to now the top 600 in just a matter of 6 or even less than that, maybe 5 months. And that shows the power of this. A great example of that is actually also something called CureCoin. So CureCoin is the #1 donator at Folding at Home. And that's very interesting because it shows that when you do something very structured when it comes to a community effort or a collaborative effort, it really unleashes the power in the community. Because CureCoin is based on a proof of stake protocol that selects pools for rewards, but it also have a proof of work protocol. But it's very different than other proof of work protocols because it's actually donating the CPU and GPU power to Folding at Home currently, and it could also donate to other projects in the future. And again, since they are actually the #1, that shows in donation of GPU and CPU power, that shows if you just structure it a bit, if you think it through and make solutions for how people can do better and do good efforts, they will do it. And so for me, that's actually serves as the very first powerful example of us. We could do better. We could do better than these off-chain collaborations. We can get them on the chain itself, on the blockchain, and then we can do more efficiently and more good for the community. The other example I want to look at is something called Kiva Lending. So Kiva Lending is basically at least how it's been used by me. It's a micro lending site where you can lend out loans to small projects, like a shop owner who can increase its stock inventory to sell more, or someone wanting a bit money for tuition so they can do a vocational skill, or for agriculture projects. So it's very meaningful because it's just a loan and they're mostly trying to pay back and they're succeeding, and it's great to cheer others on. And the Cardano community has had a forum post thread where they suggested we start our own team, and they did, and I joined this later as a staking pool operator because I see now I have rewards from the incentivized testnet. I want to give something back. And one of those ways is charity. And actually, just that small community already donated $8,000. And I find that interesting as well because it's a very unstructured, it's a very good effort, but it's very unstructured. And an example of the power to unleash, I guess, is BitcoinTuesday.org. It has a discussion about actually donations to charities that accept cryptocurrencies and how this could have some potential tax benefits. I'm certainly no tax advisor, and I'm just referring to what they're claiming on their own site. But wouldn't it be very interesting if there is some possibilities for some, say, tax benefits from donations, that a smart contract, for example, could calculate for you. Okay, you're from this country. These are the laws here. This is the tax laws here in this country. Here is your current holdings. If you did this donation, it would have this type of benefit, and the smart contract would handle the documentation and all those regulatory requirements. I suspect if we had something like that type of smart contract, we will see a lot more contribution to good charity causes. So again, that's another example how these type of kind community efforts, they're great, but just imagine if we put them also on the chain itself, on the blockchain as projects, how much power we can unleash. And those are the two small projects I want to mention, but before we move on, I should just briefly say that of course there's so many other collaborations. I have not mentioned how the ambassadors collaborate with the community, how there's a website popping up like pooltools.io and many others such as it to give information to the community. And for example, the guild pool operators, they are giving guides to the community, and there's so many guides and so many sharing information in this community. And I guess it's also human. It's in human nature. We try to collaborate with each other. So I could have mentioned many other, but the key takeaway here is that we are doing collaborations already. It's starting in small scale. And I believe if we try to focus more the effort into on-chain collaborations, we can unleash much more power. So, okay, we're in the slide 4 where we're talking a bit on and off-chain discussion examples. I already mentioned earlier that there's a discussion now about should we continue the ITN. But before that, there was also a big discussion that's still ongoing, and that's about the pledge influence factor. So the pledge influence factor is a factor for staking pool owners and operators. When they delegate to the pool, they can get a slightly higher reward if they are not just delegating, they have to pledge it to the pool. And if they don't have this pledged amount, they actually lose rewards. But if they do have this pledged award, they will have an increase in the reward percentage total by some influence, this pledge influence factor. And the reason it's a big debate is because on the one hand, it's trying to protect versus a specific attack. I will explain that a bit more. But on the other hand, if you set this pledge factor too high, you're basically making barriers of entry to others who don't have ADA. And for example, what about the more poorer countries, the countries we're really trying to help now leapfrog the financial infrastructure by providing Cardano? For the trust and for the decentralization, the global decentralization of Cardano, we should have staking pool operators also in these type of countries that they can feel this is our community too. And if you set the pledge factor too high, there will to only be a very small portion, the very richest in these countries who will be able to afford it. Of course, that's a bit extreme example, but it shows like a bit of the thinking behind the debate. And the premise is really that should the pool operator with the most efficient and best service be the one who have the highest reward, or should you be rewarded just simply for holding ADA, that you have more ADA? But on the other hand, as I said, I will try to explain the other side a bit. You're trying to prevent a specific type of attack called a Sybil attack. Basically, it's a case of having many identities. You can be a single pool operator who have many pools, and you can claim them to be from different operators because it's very hard to track your identity. Or you could be frank about it, as during the ITN there was many pools from the same pool operator, and he just had number 1, 2, 3, 4, 5, etc. And because you delegate to these pools, you can actually get a very high proportion of the total network influence who creates the blocks. And if you get a majority at some limit, then you can actually start to influence and decide and even corrupt and make changes to the network if you have enough of that majority. So you have to try to prevent this type of attack. And the way you do it is to make it costly to make more pools, because you will not be as competitive if you spread your pledged ADA across many pools. So that is the other side of the coin. But my problem has not been that we have this discussion. I think more the key takeaway to have here is that we need to structure this discussion better, I think. We have had some great discussions on the Cardano effect, for example. We had polls on Twitter and many talks in the Telegram groups. But we don't have really a formalized way of discussing this very important topic. For example, what if we had some form of work conference where we invited different experts from the different entities, IOHK, Emergo, Cardano Foundation, and they will try to explain how they see a good value and what they believe should go into these values based on their own research. And then we could also invite community members to give their view, for example, the ambassadors or some community expert that have gotten some knowledge on the topic. And then, of course, after we present all this type of discussion, then you do the voting, then you collect the data and you do it properly. You don't do a Twitter poll. You do a official Cardano Foundation survey, and you make sure to structure the questions in a good way based on the workshop, what you have come looking at, what alternatives you have looked at, for example. And then you verify the data in large enough samples that you have a more confidence in the proposed pledge factor. That's just an example, and it's a bit naive example. I'm sure we will figure out better ways, but my point is we need to structure this type of debates because they have huge implications. This pledging factor could influence what type of pool operators we'll have in this first generation of pool operators and how it will develop in the different countries. So I think it's quite important we try to structure this debate better. So that's the first example of the, I guess you can call it an off-chain discussion, but we'll later vote on it, so it will be an on-chain discussion as well. But the other thing I want to show is the system we're going to have. That's there's a great research article on this, on the treasury system, and basically it's not just a treasury system for projects, it's a system that can be used for decentralized collaborative decision making. So it has a lot of potential, and it's a very nice system because it's trying to make the best of two worlds. It's trying to make the best of a representative democracy and also direct democracy. So how does it do that? It does that with something called a liquid democracy, meaning you can actually vote yourself, but you can also delegate your vote to an expert, and you can do that for each individual topic. So that's why it's called a liquid. If you feel confident on a topic, you can vote yourself. If you feel you want to delegate to an expert on a topic, you can do that as well. And I think that's a really exciting way of looking at voting and how we make decisions, because it can be more efficient. But for this to vote, for this voting process, I will later also see some criticism as well, something we need to look into. For example, in the experts, we'll talk about that soon. And another interesting aspect of it is that you have a weighted vote, and that means that you will get a voting amount based on the amount of deposited ADA, in this case for Cardano, that you have, and that also has some effect in the voting process, and we'll discuss that too in another slide. And another interesting proportion of this treasury system is that it's an end-to-end verified result, and that means that even there's a committee that counts the results and tallies up the results, but they can never corrupt any of the results. At worst, they could delay the results by choosing not to publish it, but they cannot, due to this encryption method, they cannot change the vote of the individual user or the expert that have been delegated votes. So how it moves from the vote is that you have this type of ranking system where you have projects in different categories, and the categories are based on actually a Dash community experience and a paper they had. And they have these categories of funding because if not, you would risk underfunding some critical areas. For example, documentation. Nobody believes that's the most important thing for the start of a cryptocurrency. If you ask the global community, they probably will look at marketing, probably look at, we need to fund these projects. But simple stuff like documentation, so to make sure we have everything properly documented, is also important. And you get that when you do this type of categories system. You get more of protection that every type of important category will be funded. The other part of it is that, and this is a problem, I guess, in my opinion, is that you're voting universally on project, meaning that every user of the Cardano has the ability to vote on every single project. And since there's a threshold limit, I will talk more about that later, but basically that means that if you are not above this threshold, you will not have your chance to be in the list of the project that will get funded. And what this will mean is that there's a very slim chance that, say, a city, a local city, or even a small country will get their project funded, because it will only be the big, very broad scale type of project that will get this type of high votes that is needed for getting above the threshold and getting enough that you will be funded. So I think it's a great for the start of Cardano. as we need this broad scale type of projects, but we also will need later more localized project. If we're going to be a blockchain for the Africa continent, for example, we need to have local projects in the individual cities and more smaller, with less funding requirements, but certainly more of them. And for that, I believe we will need another type of voting, at least not a threshold that will limit these type of projects. So in the slide 5, we'll shortly look at the Cardano improvement proposals, and this is the community's most structured way of debating and documenting proposals and proposals for major changes to the network, for example. And they are formalized documents for the Cardano community, and first Cardano improvement proposal, or SIP, actually describes that currently there are 3 types of SIPs: the process SIPs, and that's more about describing processes in the ecosystem, and informational SIPs, that's more about documentation, about giving information about the topic, as we have spoken about earlier, for example, for voting about pledge factor. And then you have standard track. These are the basically the proposals for network changes, for example, or for how we do voting, for example, I guess. So they are the broader term proposals. It's important to understand the SIPs are not binding. They're more of a documentation and structured way of the debate. It's not a legally binding document in that way. And they're not the governance process itself. They're not the voting part. They're more of a discussion in the community. But I think it's really nice to show the SIPs, because they are a very good example of doing a structured debate where you actually have some requirements for what type of information you have to give, how you will give it, and it's peer reviewed, or in this case it's not just a peer, but it's a editorial team from the 3 entities that will look into the proposal with suggestions and could ask for revisions, and even if they believe it's not good enough, they can reject it. And yes, that's a bit decentralized, a centralized process indeed, but these editors are of course held accountable by the community, so I would say it's still a very much a decentralized process. So the SIPs are, as I said, like more technical documents. And since this is a presentation when I'm trying to say let's do better, I will also offer a bit critique. But I really like the SIPs. I just want to emphasize that. But are they too slow moving? Because there are many type of improvement proposals in the other cryptocurrencies. For example, Bitcoin improvement proposals, or BIPs. And you have maybe 136, if I have counted correctly, certainly a low amount. And I guess that's one of the reasons is the nature of these. These are very broad changes that needs to get usually a broad adoption from the community before they are actually implemented. So that's very slow moving in nature by itself. But for Cardano in particular, Cardano uses a very strict and rigorous scientific method. They mostly use models and formal methods, and with the formal methods they verify mathematically that what they are claiming is correct from a mathematical standpoint. They can look through the variables and prove they will be as they are claiming they will be. And that, I guess, sometimes could be a very high barrier of entry to quite technical expertise companies still. And maybe not all type of SIPs require this very formal approach. And I believe it will be very interesting if we can try to learn from all of the other improvement proposals, like the BIPs, the Bitcoin improvement proposal, or the Ethereum improvement proposals, and try to learn like what was the success factor, what was the best way to structure it, what ended up with the most successful type of projects. What type of group of SIPs should there be? Should there be more than 3, or is it better with a very fine mesh or a very broad mesh, for example? So all I'm saying is I really like we have a structured debate, but I also wish can we do better here? Can we look more research into it? Okay, so slide 6. Here I'm trying to show that the current research effort by IOHK, as they publish on the iohk.io website, it's quite lacking when it comes to social collaborative mechanisms. I tried to look at all the research articles. There was 75 when I was doing this recording, and many are about game theory, of course, because that's an important part of proof of stake. You need to have a sort of equilibrium between the different parties, how to do what's best for you, but also best for the network itself. And while you could of course say that's social processes, it's not social collaborative mechanisms for some result other than maintaining the network. So I discarded those, and also did not include one article about communication across the distributed ledger, as that's more about how different cryptocurrencies, for example, would communicate across each type of database or distributed ledger. But the two treasury articles by Cardano, one that was on Ethereum Classic and one that's now for Cardano itself, they are truly very good research article for social collaborative mechanisms, as they are looking very carefully at voting in the Ethereum paper, and they also are discussing very well in the latest treasury paper how to use this mechanism as a sort of a collaborative decision-making process that's decentralized. So those are definitely included. And I think also there's another article on the collaborative mechanisms, but in total 3 articles out of 75. So as you can guess, that's not that big a proportion of the research articles. To be fair, this is natural in the light that right now it's the most important to have the technical implementation, and then you look more into the use case. But for me, it's more of a question, can we afford not to give much effort into the collaborative decision-making process? Because after the Cardano 3rd generation, there will be a 4th generation cryptocurrency, there will be a 5th generation cryptocurrency. And you need mechanisms to keep reinvigorating yourself, to keep updating both the on-chain and the off-chain community. And for that, you need to have good collaborative decision-making processes. And another thing is that I think Cardano itself acknowledges this. For example, Cardano Foundation has an article from August 2019 where they are already saying they are trying to fund more blockchain research. So they're trying to do more research into this field, but I think that we can definitely do even better, and we should look perhaps in particular now, because it will be the most important for governance issues, into voting and the voting process itself. So that's going to be the next slide, the slide 7. We will look a bit more about some of the voting theory, and it's based on the Ethereum article. So let's move on to the next slide. So in this slide, we'll now look at some voting methods, and this is based on the Cardano Classic Treasury paper that discusses some broad difference between the different voting methods. And in this case, 4 categories: plurality voting, majority voting, and preferential or ranked voting, and cardinal or rated voting. And each of these voting methods has its different pros and cons, and that in itself shows that you should try to pick a voting method that fits the situation you're trying to vote in, and carefully look at the different benefits and what's not the benefits of such a voting system. So let's look a bit at those voting systems. In preferential voting, you vote for one candidate only. It's a winner takes it all type of system, and the problem with that is that you get something called strategic voting, meaning that you could have voters who would not vote for who they think is the best candidate in case of candidates, or let's say a project, but they will vote on the one that's more likely to succeed. And the reason it's because when there's a winner takes it all, they would try to avoid that some project that they strongly disagree with or a candidate they strongly disagree with wins. So they would try to look, okay, strategically I should probably not vote my favorite because he's not likely to win. There's not many other thinking he's a favorite, but this other candidate, he's much better than the third candidate, so I will vote on him instead. And that's the essence of this strategic voting strategy. And it's the same for what's called the majority voting, but here, unlike in a simple majority, you need to have more than the other candidates total in number of votes that you get. So let's say there's 3 other candidates, they have a total of 20 votes. You will need to have 21 votes or more to actually have that majority done. And it has the same problems as the plurality vote in that you have strategic voting. The third, or another historical example of this is how they vote for the Doge of Venice. So the Doge of Venice was voted for life, and interestingly enough, they tended to vote for the oldest oldest candidate, the one that would live the least longest. But anyways, in such a system, you tried your very best to make sure you got the good candidate because it was meant to be for life. And it was very elaborate, and this elaboration, it did not really mean any more security or better way of voting, but in those times in Italy, in many cities there was many corruption, and many were trying to have this feeling of a fair process of voting. So there's some sense of security when you feel that it's very elaborate. Oh, it must be very careful then, and because you need to have tenacity and to actually finish such a process. And it's actually consisted of 10 rounds of voting or more, and it was based on all the different oligarchs of Venice, and everyone over the age of 30 could be picked, and it was picked by some random sampling. And then from that random sampling, an electorate was taken, and that electorate would vote then on another group, and then there was more processes with more random sampling and more groups, until finally you ended up with a final group that would actually vote on the Doge of Venice. So one interesting property of this is the fact that you use random sampling. In itself, that has an interesting property in that you could get any single of the members of the oligarchs to have a say. And why is that important? Well, for example, we talked earlier about local projects or the local voice. So in a Cardano community, if you could have some form of minority to have a say, I believe that could be a good process for many types of voting. Not for all, but for many types to feel that, the minority, even if you don't own the biggest amount of ADA, you will always have a chance to have a say. And it's just like how you select blocks on the blockchain. You will always have a chance. Even if you have a small amount of ADA, you will have a chance. And I think it would be very interesting if we look more into how we can use random sampling for a voting process. Perhaps there's some benefits to have from that. Perhaps we can learn something about the voting process itself. Perhaps you can do it more efficiently. Do we have to vote everyone to vote on every type of voting process? So while the Doge of Venice was a very elaborate method, perhaps we can learn something from that history. But moving on to more of the other voting methods, that's not so historical but more current. You also have the preferential vote. It's ranked voting, and you have this cardinal or rated voting. And in the preferential voting, you have scales, how much you prefer a candidate. So you can have this candidate number 1 that you prefer the most, and the candidate number 2 that you prefer slightly less, but more than the third candidate. And you basically rate them on this scale. This system has also its pros and cons, and one of the cons of this is you could actually elect someone who would not have won against any of the other candidates in a one-on-one situation, but because they are the most preferred, second most preferred by many, you could end up with this. Just to show an example of this type of voting is, let's say you use instant runoff voting. And in an instant runoff voting, you if someone is preferred the most with 50% or more, that's no problem. You select that candidate. But if you don't have a 50% majority, then you would, instead of doing a new vote, you would instantly discard the one with the least popular candidate, and then you will count the second preferred for those votes. And this process you will repeat until one candidate has 50% or more. So you can see how that would actually, in some cases, make a winner that will never have won versus all the other candidates one-on-one. But because of how this process is structured, this candidate is the most preferred by, as a second most preferred by many others, and could actually win when there's no majority in the first part of the process. And the other type of voting system is the cardinal or cardinal voting system. And in this type of voting, you use approval ratings, for example, and the one who has the highest number of, for example, in a simple method, you have yes or no. And the one that has the most yes and least no's, and the total score of that, that's the winner. You can use this for a single winner or for multiple winner elections or multiple projects. This voting method in the literature is discussed has a tendency to give more moderate winners, because you can vote on many projects that you say, or many candidates. Oh, I would like this candidate, or this other candidate is also okay, and this third is also okay. And you tend then, if you do that over a large group of data or a large group of people to vote, you will get more that everyone prefers somewhat enough to say yes, and that's the more likable candidate. So in many cases you will have a more moderate winner. Cardano Treasury uses a form of this cardinal voting method, and the use of form that's more advanced, it's called a combined approval rating, because they use something in the voting process. They use yes, no, or abstain, and that abstain part is actually quite important, because instead of having to say, yeah, I like this candidate, but this one is also okay, and certainly better than the third candidate that I don't like and would vote no against, you could actually say, yes, I like this candidate. Oh, this candidate I don't dislike, but I don't really like him either. I will abstain from voting for him, and or in this case, abstain from the whole voting process or also for that candidate. And you could also vote no for the one you most strongly dislike. So in this system, you would try to circumvent a bit the problem with having these moderate winners. And the Treasury also has some other mechanisms. It's called a fuzzy threshold voting, and that means there's a threshold, meaning that any, in this case, project for a treasury that doesn't have 10% support or more, they will never be included in a list for that category of proposals. And that is because, I guess, Cardano wants to have broad approval for its project. They don't want to fund a project that doesn't have some approval, but discussed earlier, this would probably discourage more local projects in the start, and we perhaps need other mechanisms for those type of projects. But it's not only have a threshold of 10%, it also have what's called fuzzy. It's a fuzzy threshold voting. And the fuzzy part comes from the fact that even if you have the most vote, if there's not enough treasury budget left for that category in that treasury period, you will not get funded. So you will move on to the next ranking on the list, and you could have lesser votes, but you have a lesser budget requirement, and then you could win actually if the other project required too much compared with what was left in the treasury. So that's where the fuzzy part comes in. And I hope that with this shown that there's are pros and cons to every type of voting system. And in the next slide, we'll look a bit at some of the, I guess, what I have thought of could be some attacks or ways to game this system a bit. And that's just for a debate on how we can look at these voting methods. So let's move on to the next slide. So in this slide, we'll look at some example of attack vectors in such a treasury voting system. So in the treasury voting system, you have what's called weighted votes, meaning that how much ADA you deposit will actually influence how much vote you have, or how much say you have, or influence you have in a vote. And that is important because it protects against a form of Sybil attack for the voting process itself. Because also in a voting process, if you could have one vote for each user, you could easily have an attack vector where one user would try to fake identities or make many identities and use that as a way to influence the vote. In a weighted vote, that's harder because it would be more costly for you to do, and you would have to have the majority of the ADA to try to vote something malicious. And of course, since you have that large amount of ADA invested, you will not want to do something malicious because you want ADA or Cardano to succeed. But the problem here is that in a liquid democracy, you can also delegate to experts. And just as you could have problems with pool operators in how they are delegated to, and if you don't protect against the Sybil attack, we should think carefully about experts in this liquid democracy. As experts work now, I believe there's no formal reputation system, and that means that an expert could be doing well and seeming like a good actor, and then they could vote what's in their own best interest, or what's in the interest of a few of the delegators and not all of them. But if you have some form of proof of reputation or some form of reputation system, you would actually have less of this behavior, because the user could, let's say, you could show how did the expert vote previously to build up a history, and that gives more trust in their decisions. And you could say, for example, look at how did the projects that this expert voted yes for do, did they succeed, and stuff like that. And if you have this reputation, there's less incentive for an expert to vote differently, because his decisions are actually tracked, and the ones who get more likely to be delegated to would obviously, from a game theory point, be the ones that are most active, most thorough, and doing the most success. And so you would encourage the good actors in such a system. So I believe we need to have some form of proof system. And I briefly said proof of reputation. That's actually some research done by something called SingularityNet, and it's too big of a topic for this presentation. But you can Google it, proof of reputation by SingularityNet, and that looks at some mathematical forms to look at reputation and represent it mathematically. So I think that's would be another interesting research topic to protect against Sybil attack for the experts, as a way to circumvent the protection offered by having a deposit on a weighted vote. Another topic is how there could be black swan events in this type of system. And as far as I know, there's no rollback method in the treasury voting system, meaning that if some form of natural catastrophe or some unthought of event that was very unlikely suddenly happens, there's no way to roll back a voting process. And it could be simpler than that. It could be, let's say there's a company that has some criminal activity, and you have founded this or voted to found this project, and it's the voting is almost done, because voting happens over a period of time. And if there's no rollback, then you could actually help found a criminal activity, and maybe even the Cardano treasury system could be held accountable or liable for this. Who knows? But you could avoid this if you have a rollback system. And of course, it needs to have the highest standard of thresholds, and perhaps should be structured the same as the SIP, where you have some form of council or editorial or some form of expert that would actually say, yes, we want to do a rollback, and then you should have some very strict measures like a majority vote or something very strict to actually do such a rollback. But history is full of examples of having to redo elections, natural disasters, and just like now with the pandemic. So you should have a system, if it's going to last, and the idea it's supposed to last for eternity, you need to have a system that is also robust to events that are very unlikely. That's called the black swan events, the one that you always observe this white swan, but suddenly there's a black swan. You have been disproven. The world is not as you thought it was. There is also black swans. And the case could be very well like that for cryptocurrency projects. You can have founded in a certain direction, and suddenly there's a new technology turning up on its head everything, and you needed to do another change of direction. And that brings me to the fact that how we found projects needs to be researched into also. What are success factors? How do we most efficiently use the funding? Should funding be all at once? If you win the vote, you get unlocked the whole treasury amount, or should it be more like gradually? How are these proposals for the project structured? Do they ask for funding for milestones and such? So I guess a lot could be said about that, but the point is that if we have this type of events, we need to have a way to roll back from them, and we need to also look at how we do funding. Of course, the other side of the coin is that these companies trying to vote, or this private person trying to get a project approved, they need also some form of security. So you need a middle ground where you unlock funding gradually. I think is the best approach. And finally, and the last issue I want to mention is artificial intelligence or Internet of Things devices. So in 2020, according to Statistica.com, there's going to be around 20 billion Internet of Things devices. That's a lot of mobile phones, a lot of tablets. And that also means that in the future, if we're going to run smart contracts on these devices, they are likely to have ADA, if this is on Cardano, and then they could likely be used for voting. So you could have corporations producing these devices, and let's say they use this ADA as a way of communicating or of paying for fees on the device itself. They could actually use the free float of these fees, the one that's always circulation, as a way to vote and influence voting. And if this was a large enough scale, that could actually have a major influence on a voting process. And they could even vote for their own type of projects if they are producing devices for Cardano. So another example would be hackers. They could try to gain control over these devices and then use them for voting. And finally, it's perhaps not so far-fetched to think that with the current development of artificial intelligence, so fast it's moving, we could also have smart contracts that wants to have a say in a voting process themselves. So in the last slide before the ending, we'll look a bit at binding agreements. And it's just because it's been an interest of mine since 2018, as I discussed in one of the first slides. So to show a bit about binding agreements in the case of a legal domain-specific language, we should look a bit at smart contracts and also a bit at Marlowe, a financial domain-specific language. So the basic premise of a smart contract is that through the code you will guarantee that a process will be done. Code is law, and this works as long as all the code is on the chain itself, on the blockchain. But as soon as you put some code off-chain, you can rewrite the program, you could turn off the computers, you can change the code, and code is no longer law. So you need to find some other way of making binding agreements. And the Marlowe system is a great example of how you can try to simplify contracts. It simplifies with something called a Marlowe playground, and it does this by making almost like this Lego blocks type of system. You drag and drop, and you drag it onto this playground, and you make logical connections with it, so you can easily construct a contract. And in this case, it's designed to be a financial domain-specific language. So it's structured for financial experts to understand it, and they can use it without any advanced knowledge of Haskell, so it eases the threshold. And that illustrates something, because when we move to a legal domain-specific language, you need also to simplify it. As this is the one problem that has plagued law for so long. Basically, if you try to make a specific law for any specific case, you will have so many laws that everyone will start to lose count. And the other approach is that you would try to make the intent of the law. So you would write the law with its preamble and its description of what's the purpose of this law, and then you have this huge profession of lawyers or legal interpreters who would then try to say what would probably happen in a court case, what is really the intent of this law, how should we interpret it. And both of these approaches means that it will be quite expensive if you move into some legal gray area or you're unsure of some topic to actually have an overview. And I guess it's come to a point where even lawyers themselves sometimes have to say it depends, because there's so many alternatives. Wouldn't it be great if you could try to simplify this a bit? And that's, I guess, is the approach of the research that's been done on legal domain-specific language, because what they're trying to do is to try to limit the language. First, in a 1957 research paper from Yale Law, they look at how to use symbolic logic, something called denotic logic, to simplify a legal drafting process. By using these mathematical symbols, they can express prohibitions and also permissions, for example, and they can do it in a mathematical way. So this is something a computer will understand, and that's interesting. And another on the papers I've been looking at, they try to simplify the language itself. They use something called a controlled natural language, and that's just a subset of a language that linguistics have looked at and try to simplify so that it's more easy to see the clear meaning or intent of the words used. And the advantage also of a controlled natural language is it's much easier to translate. So you could do this Marlowe type of block system with a playground, and you could, like, for example, instantly translate on the fly the meaning behind the words to different languages. And that I find an interesting topic. So also you try to limit the grammatical structure, and they have something called a grammatical framework, this linguistics who have looked at this. And in this grammatical framework, they also try to make sure that no meaning is lost in translation between the different languages. I guess that shows just a small example of what we can reach for in the future, because imagine we could actually translate and make this type of legal contracts, and we make them easy to visualize and easy for users to agree upon, and to show visually what's the structure of this contract. And that would mean you could start to make even more type of collaborations, because you could make them more formal and you could trust them more, because you would have protection from the legal system of those countries where you used as templates for your contract. And I guess that's an okay way to end this presentation, just a small sample of another research topic. I believe we can just try to do better. We can try to reach for more. We're already going so far, and it's really exciting to see, and it's been a pleasure to be able to present here. So in this ending slide, I just want to thank everyone for listening this far, and I hope you enjoyed the presentation and got some inspiration on some of the topics that we can do better on in the governance. And I will just end it with a small introduction video to my staking pool, ADA Nord Pool. And for those who don't want to watch, this is the end of the presentation. Thank you so much for listening. Hi, I'm Eystein Hansen of ADA Nord Pool. I would like to give you some reasons to consider staking with me, and also some reasons to consider if Cardano pool operators are not your average pool operators. So please grab some popcorn and give me 1 more minute of your time.